Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Okay, so everyone, it's great for this to introduce Khalid, and he's a PhD student of Carlos Gaston's. And he did really fantastic work on personalization from Twitter and badges. So,
okay. Thanks, Laura. So I probably don't need to tell many people in this audience, but personalization is ubiquitous today. So, maybe the first kind of mainstream example of personalization was Amazon.com's recommendation for what you should buy. But quickly this spread to search and entertainment like movie rental, YouTube, TiVo, Hulu, listening to music, getting your news, the millions of Twitter feeds, who do you follow, your recommended friends on social networks, and then there's another kind of social network that is very heavily personalized, these dating sites. And so, personalization is all around us, and it's also invaluable. So YouTube has 24 hours of new video uploaded every minute. Facebook, as of this month, has over 750 million users. Their Twitter last month reached a 200 million tweet a day threshold, and I like this stat. So in 1994, there were 500,000 unique goods sold in America, and last year, Amazon.com sold 24 million goods. So this shows the serious information overload problem that you need some way of personalizing to your taste in order to be able to get at this. And so here's another kind of flavor of personalization. So let's say someone comes to you and says, tell me about this debt crisis in the US. You can show them an article from the Huffington Post or from Fox News. And so how do you decide, which to pick? Again, someone's going to a website with reviews, and it's at, they want to find out more about a particular coffee shop in Cambridge because they've never been to Cambridge before, and they see 2 reviews, and they're total opposites of each other. So how do they know which one to believe? And so these are examples of really why personalization is important, so you can actually, make a good judgment in these cases. And unfortunately, personalization is often wrong. And so this is from a great article in the Wall Street Journal 8 years ago, where I guess TiVo is not, I don't know how popular this is, these types of services are in Europe, but, so does everyone know what TiVo is? It's this like digital video recording kind of device. And when it first came out, it tries to personalize, recommend shows for you to record. And there's this whole article in the Wall Street Journal where they're describing, this is one of the earliest examples of personalization, and they're describing how people were baffled by the shows that TiVo was recommending to them. And people were just very frustrated, and there's no real way for them to, to get around this. And this is more personally, so this is an example of poor personalization. So, I got this recommended to me on Facebook as an Egyptian, democracy activist. This is not what I want to see when I log on to Facebook. But in Facebook, we could, the way you deal with this problem is you might, in Facebook there will be a little X here. You can say, okay, like I don't actually, want Hosni Mubarak as my friend. And for TiVo, if you read this article, the conclusion of the article is you have to outfox TiVo. And this is very striking because we shouldn't have an adversarial relationship with something that's supposed to help us. And so what can we do about this? So this is kind of our proposal. So let's say I'm presented this article about the debt crisis, and I want to ask, why am I getting this? And imagine getting an answer. You behave like a vegan hipster, and that's why you're getting this article. And so you might be shocked and say, okay, so why am I vegan? And the system will tell you, well, you've tweeted with this hashtag, you follow Whole Foods, you do these things that are consistent with the behavior of vegans. And so you might say, actually, I'm not a vegan. And so then it'll try to explain, well, actually, you're a Brooklyn hipster. And this is another explanation for your behavior. And the key thing here is all of these are very user interpretable, and when you can drill down and see exactly what these badges mean and how that corresponds to why, like how, like why the system would have predicted that you fit this pattern. So we're going to call these badges. And so things we want to see with these badges are, first, they should be rich, because we want to use these for recommendation. And so we need to have a rich set of features such that we can recommend any sort of like news or restaurant reviews or what have you. Again, they need to be interpretable and explainable, so the users have to see them and know what they mean, and they should be able to get an explanation for why the system thinks they fit that mold. And they should definitely be correctable, because we're not going to be right all the time. And so, just to get a little more formal with our approach, I'm going to start with an example. So how might you build a vegan badge? So let's find a friend that you're pretty sure is vegan, and we'll observe his or her every action. We'll build a model of their behavior, and we'll use it to predict if anyone else is vegan. Except we're actually going to find thousands of people who we're mostly sure are vegan, and we're going to observe their actions relative to everybody else. And then, so the question is, where do we get this stuff? And we can get this from Twitter. Yeah.
So how do you actually come up with this definition of vegan?
I'll get to that in a second.
Okay.
Okay, so how do we find thousands of people who are mostly sure are vegan? Well, on Twitter, you find people with, everybody has like a couple sentences at the top that describes, who they are. And, sure enough, people say they're vegan, and it's very unlikely that you write that you're vegan in your Twitter profile and you're not actually vegan. Of course, it's not perfectly, accurate, because occasionally you have a guy like this guy who says, I drink too much and hate vegans. And so, but this is a very, small percentage of the cases where vegan appears in the profile. So second, what does it mean to observe every action here? And so we're going to define actions in Twitter to be tweeting with a hashtag or retweeting from someone. So you might tweet with this hashtag, or you retweet, something from Whole Foods. And so more generally, a badge is defined via a high precision, low recall rule, like what I just described with vegan. And what we're going to do in this setting, we're going to base it on phrases that are written by the users themselves in their Twitter posts. So it's like people self-describe themselves as vegan. And for the most part, for something like vegan, it's very unlikely that you have vegan in your profile and you're not vegan. And then we want to discover characteristic hashtags and retweets that are indicative of having this badge, and use that to infer these badges for other people. And so how do we model this? Well, let me start with some caveats. So we have no negative training examples, because we have no, we know that some people are likely to be vegan, some people are likely to be hipsters, but we don't know okay, this guy hates vegans, but in general, we don't have negative training examples here. And so we're going to use a generative model and encode, instead of assuming we have positive and negative training examples, we're going to encode this in the prior. And also, actions can be explained by multiple badges, even for the same user. And so to combine this effect, you'll see soon, we're going to have this noisy OR model to combine effects from multiple badges. And so I'm going to walk you through this model. And so, this is so our graphical model will start with this badge, this latent variable for each user U and badge I. So does this user, it's a binary variable, does the user have this badge? And this explains this variable W, which is observed. This is the actual rule indicator. Does this user have is the vegan rule active for this user? Because of course not every vegan actually writes that they're vegan. So this, but some of them have this rule active. And the other observed variable are these actions. So has user U performed action J? These are things like, they tweeted with the hashtag, I don't know, vegetarian or something. So does that make sense? And so now we're going to put a beta prior on this variable, this badge variable, and this is to control sparsity, because we don't want a user to, we want to be able to control how many badges the user has, to explain their actions with. And, so again, we have this beta Bernoulli conjugate setting here. Then over here, we can encode the low recall, high precision, basically by using the badge as kind of a gate. And so if a user has a badge, then we can encode this low recall property. So maybe we'll say like 10% of, given that you have the badge, there's a 10% chance that you actually activate the rule. If you don't have the badge, then maybe there's like a 99.9% chance that you don't actually put the rule there. Does that make sense? So this is how we encode this low recall, high precision effect. And specifically, it looks like this. And so now we'll look at the actions. So we have a binary variable per badge, per action that tells us whether this badge explains that action. Because we assume that a badge can't. It's not. Not every badge can explain every action. So we want sparsity here as well. And so we'll say that based on how we set the prior for this, we can control how expressive each badge is. And then, of course, we need to look at the importance, or how, what's given that you have a badge, what's the probability that you perform a certain action. So let's say this is let's say I is the vegan badge. So let's say vegan explains the hashtag Whole Foods, and this will be some probability. Like if you have the vegan badge, there's a 0.2 chance that you tweet with the hashtag Whole Foods. And then, of course, not everything can be explained by badges because some stuff just happens across the board. And so we have a background distribution. Again, like for each action, there's some background probability that happens regardless of which badges you have. So does all that make sense? And so this is our model. This is just some. So this is our prior. And then the way this all kind of comes together in these actions is we have this noisy OR situation where we say user U performs an action J if at least one of his or her badges or the background can explain it. So that's how we combine this here. And this is where these Sij variables come in because this is where the sparsity pattern lies. Is that clear? Okay. So now this is our model and it's full of glory, but one interesting thing is I have this example where so a user can say, oh wait, I'm not vegan. So that actually directly corresponds to observing this BI variable. And then you can do inference and figure out what other badges actually explain this user's behavior. So there's a very nice correlation between that. And so the way we do inference here, we implement a collapse Gibbs sampler in F#, where these are the only variables we care about. We don't really care about any of these variables, so we can just collapse them out of the model. And so we do collapse Gibbs sampling with some metropolis steps, and it's kind of slow actually, and because just in general when you collapse variables in a sampler, then you tie variables together, and so it's harder to parallelize, and so lots of these variables find themselves in cliques, and so we can't, at least directly, we don't parallelize anything here. So that's in order to scale this model, I'm going to have to think about better ways to do inference here. Okay, so experiments. So what we did is, I collected 7 million Twitter users, just kind of any user that had a description. Then Ulrich and I manually defined 31 just sample badges, somewhat haphazardly. We were just kind of trying to, just for the sake of an example. So we defined 31 badges, and they were all by specifying rules on the Twitter descriptions. And so we have things like Apple fanboy, runner, cyclist, photographer, and so on. And so we defined these badges. And then of the 7 million Twitter users, there are 377,000 users that actually match one of these rules. And because I didn't want to collect tweets for all 7 million, I decided so for 1 week, I looked at any time, so I just looked at the fire hose, and any time one of these users tweeted, I just saved it. And so that was 1.7 million tweets in a week. And actually, you'll see later in the results. So this is around the time when the London riots were happening. And so actually the most tweeted hashtag in this week was London riots. And so then we define actions as the unique hashtags and retweets in this set. And because some people might only tweet once in that week, or some actions are only taken by one person, we can significantly cull this data set into about 76,000 users and 32,000 unique, like a vocabulary of 32,000 actions. Does that make sense? And so just some statistics. This is on the rules, how many rules fire for each badge. And so we have a lot of people with the word artist and photographer, not so many with country music fan or bookworm. And so now I'm actually just going to show you a series of visualizations. So what you see here, so this is a word cloud that where the size of the word. So these are hashtags, and in some cases you'll see actual retweets. And the size of each word corresponds to the probability, is proportional to the probability that action is explained by this badge. And so for the vegetarian badge, we learn this very nice kind of explanatory. So imagine if someone told you have a vegetarian badge, you'd say, what does that mean? It means, the vegetarian badge explains these actions. So you can tweet with these hashtags, donating tweets, gluten-free earth. This is what it means to be vegetarian, as described by people who, but this is by starting with people who say they're vegetarian on Twitter and then inferring beyond that to see, what types of things vegetarians do. And similarly, this is the Apple fanboy badge. If you retweet from Mac Rumors or 9to5Mac, or you have this hashtag, then this is what the Apple fanboy badge explains. This is, again, learned from people. There's a surprising number of people who have the phrase Apple fanboy in their Twitter profile, and we infer from those people to others. Again, this is the hacker badge of anonymous iPhone, Apple, Android. This is the Man U badge. So you see, Community Shield, Squirrel's Legend, etc. And so now some questions. Do all the badges look this good? No, but most of them do. And I'm going to show you some examples of where this goes wrong. So can anyone guess what this badge is? Probably not. So this is a small sample size problem. This is the country music fan badge. There are only like 29 people in this data set that had country music fan in their profile, so it's very hard to start from that set and kind of infer what country music fans like. So we end up with just, so basically you can imagine in a case where there are very few people, our model will tend to just almost treat that badge as like a topic and a topic model. It can take some stuff away from the from the background distribution and take some mass from the background distribution and put it in one of these badges, because then it can do a better job of it can have better granularity of explaining the actions of certain people. We have another issue here, which we call over-generalization. So you probably won't be able to guess what this badge is. This is the wine lover badge. And you can see it over-generalized. So it's kind of related, but now you have all these kind of high life things like vintage and fashion and travel and jewelry and earrings and zazzle, I don't know what that is. But you can see it over-generalizing from, because again, there's not, maybe in our data set, because our data set is rather small, so presumably some of these problems will go away if we could actually run this on all of Twitter. So the next question is, how much of a role does initialization of the sampler play? And it definitely plays a role because, our sampler is not going, we're not running this for hundreds of thousands of samples. Our sampler will not, in theory, it shouldn't matter where we initialize, because the sampler will mix and it'll forget where it started from, but that's not the case here. But just as clever initialization doesn't, get us all the way. For example, can you guess where, which badge this is the initialization for one of the badges. This is how the Apple fanboy badge started as, and it ended with three things, Mac Rumors, iTunes, and 9to5Mac. So you can see that our model is actually, doing something. It's not just initialization. But having some sort of clever initialization is critical for these models. And so now I have one more kind of set of cool results, and this is basically the empirical distribution, the empirical marginals on pairs of badges. So what's the probability of any pair of badges occurring? And if you look at these bright spots here, you see they kind of make sense. So Apple fanboy and gamer, Apple fanboy and artist. These are kind of high co-occurrences of these badges. Photographer and artist, jQuery and entrepreneur, Harry Potter and Taylor Swift. These are all kind of high frequency pairs of badges. You have coffee and artist, and this is, so now there are two particular badges that are, like, so I think these are both from a small sample size thing, and so what happens, the coffee badge actually is the last FM badge. Basically, there weren't enough people that said they were like coffee lovers in this data set, so it just kind of decided there are enough people that tweet with the hashtag lastfm that it's just going to be its own badge. And so this is really lastfm and artists. So that makes sense. And then if you remember the country, so this is another, I think Ruby on Rails is one of the badges, and there weren't a lot of people that have Ruby on Rails in their profile, so it made this the London Riots badge. Like all the London Riots words just kind of, showed up in this badge. And now I can look at, that's why first of all it correlates with lots of these other badges, because everybody was, or a lot of people were talking about the London Riots, and in particular the highest levels are Apple fanboy, photographer, gamer, and feminist. And the interesting thing, I don't have it here, but the feminist badge generalized to an activist badge. So instead of just getting feminism things, you also got like Somalia famine, Libya, Syria, and it was all these kind of activism kind of types of words. Okay, so now I want to talk a little bit about future work, because we hope to write a paper about this soon. And so immediate things are quantitative evaluation. So things like this are very hard to evaluate. And one thing we can think of is to learn kind of independent classifiers for each badge. And then, you can get around this no negative training data issue by just picking random other data points and saying those are negative examples. And also, it would be nice to actually make this into a full system where you can do a user study and ask people, like, is this, like you deploy these badges in the way that we intended for them to be used, and kind of see how users behave. And something I want to, it might be ambitious, but I want to see if I want to be able to scale this model to huge data sets, like all of Twitter. This is kind of a challenge for me. And because we have lots of these nice models that we come up with, and it's very difficult to actually, 80,000 users, so what? They're 200 million tweets a day. Like, how can we actually get this to work on a really large scale? And also, part of this is time is a factor. So I just took a snapshot. If I go in like a few weeks, no one's going to be tweeting about the London riots. And so, your set of badges might stay the same, but so you might always be a vegetarian, but what it means to be a vegetarian will change, what actions you might take. And so that's something that needs to be modeled. And there are a couple of other things, like Ulrich and I aren't going to define all the badges in the world. So, we think there needs to be some nice crowdsourced way to get expert, and it has to be controlled, but to get experts to kind of define badges. And then once we have all that, we actually want to build a recommendation engine that uses these features, because none of this matters for personalization if you can't actually recommend anything using these features. And one initial thought we had was to model trust, because a retweet in Twitter is an explicit indication of trust. You're trusting the person you're retweeting from with respect to whatever topic you're tweeting. And if I can just take every user on Twitter, convert them to a set of badges, and I have this massive data set, learn from all retweets of which types of users trust which other types of users with respect to which topics, maybe we can use that for personalization. And then, so to summarize, we proposed a framework for addressing transparency issues in personalization, and we designed a graphical model to encode this, and did some good sampling for inference, and our preliminary results show that we actually get interpretable badges that we learned from real Twitter data. So that's it. Do you have any questions?
So, do you think there's any scope for unsupervised learning of the badges? Do you have any feel
Like for the badge definitions?
Yeah.
Um,
Like, let's say London riots, suddenly, it's a big thing in the news, and somebody forgot, or, whatever mechanism we invent, somebody forgot to define a badge for it. And suddenly lots and lots of people start, reporting on London riots, and it sort of messes with the existing badges. Do you think there's any scope for, in an unsupervised way, detecting?
So I think the London riots case might be more, so the badges are supposed to tie to like traits of users. And so unless you're it's hard to, the London riots seem like something that should be taken into a background kind of distribution rather than, so the problem with unsupervised approaches here is that it's dangerous and that at the end you might not, there are lots of approaches that try to get interpretable kind of features, but they're not, here by controlling the badge definitions, we can actually, it makes, you can tell, we're really kind of forcing, we don't have an identifiability issue. It's not, with LDA or that doesn't, it's hard, there's identifiability issues because topic 5 and topic 12 can kind of alternate and you have no idea. Here it's this is the vegan badge and I think that'll be hard to do with unsupervised approaches. Tashmir?
So basically what I see is there's a problem in the representational issue. So what the model is basically capturing is people who are vegans and also have this trait that they expose that fact on Twitter or on Flickr, right? So if say I am a Windows user, but I don't support Republican Party, right? Most Windows users don't support a Republican Party, but it just may happen that most of the Republican Party supporters have Windows in their tags. In the profile. So when you are making this tag for say the Republican Party, you would now see that okay, the Windows is sort of always common with the Republican Party tag. So the core issue is that it's not just, it's basically also the model should also explicitly capture the fact that some people might not expose the fact. You're only looking at a small subset of the eventual users who have exposed that preference for that tag.
So I'm trying to encode that with the low recall, the beta distribution, in the case that you have the badge but don't expose the rule. So there's that beta distribution is still you're still unlikely to given that you have the badge. Let's say there's only a 5% chance that you actually fire that rule. So that's worked into the model, but you're right. So one choice we made is that you can imagine having. So I wrote out another version of this that was a mixture model, and you have this variable that decides which badge each tweet comes from, and so and you end up with you have these Dirichlet distributions, the Dirichlet kind of priors over your action vectors, and we don't want we want it to be possible that. If 80% of Republicans use Windows, then that Republican Party should explain Windows with 0.8 probability. Likewise, Microsoft employees, right? That there will also be 0.999, probability for the Windows action. And so, it's hard to tell how well it can suss those differences out on the small data set. It'd be not lots of these things will become clear once we can run it on really large data sets. Because this is the type of thing that you can definitely see it get better as you use more data. Yes.
Maybe this is related to your comment about mixtures, but I don't consider myself labelled by, say, interested in machine learning and interested in aeroplanes at any one time. I'm sort of interested in machine learning, and then later on in the day, I'm more interested in aeroplanes.
Yeah.
And so have you thought about that sort of temporal issue in that context?
Yeah, so that's why, actually after we wrote this model out, I didn't have time to implement it and compare, but you can say that when you tweet, you're only tweeting with one of your badges. And so I have the model right now, I just want to implement it and compare, basically
There's something more sophisticated than that, isn't there? There's something where I have these different personalities, and one of them is a combination of badges, and another one's a different combination of badges.
Oh, okay, yeah. So your badge profile changes over time, or
Well, with the context,
Yeah.
last Saturday I was interested in aeroplanes and I've forgotten about it for an entire week, and now suddenly I'm interested in it again. And
Yeah. No, that's definitely like. So you have different personas in some sense, and
yeah.
So what's the difficulty in the inference here that would stop you from using a deterministic inference scheme, like a variation
Or infer.net.
no, there's no. I mean,
That's my next questions.
no. Just because I was like, it was most natural for me to write it out as a Gibbs sampler. That was the first thing I tried. Like, there's nothing that would stop me from trying a variational approach or something else. This is what I was most comfortable with, so I just like wrote out.
Right. I mean, I do know that the noisy or construction has been used, for example, to explain symptoms from illnesses or underlying diseases. And there are some difficulties in the inference, and they use corrections to relieve propagation. And, so I mean, it's probably not trivial to do. But
I mean, the other question is if it works just as well if I use a mixture model that has more, this noisy OR thing breaks all sorts of conjugacy like in this segment, and if I can make the model more susceptible to inference, and while it still performs well, that's another thing to consider.
yeah.
Yeah.
Yeah, so I mean, you started by saying your goal was that these badges should have a meaning, that if a badge has a certain title, it should mean a set of actions the user can understand. But in your learning, it showed that in many cases that was not the case. So a badge such as coffee does not correspond to what the user would what the action should be.
So in many of those were these small sample issues. Like for instance, country music fan, when I showed you that really bad badge, that there were like just a few, like in our little data set, there weren't that many people that had that phrase. And like I'd say out of the 31 badge, I have them all upstairs, out of the 31, maybe 28, 27 were like really good. And then there were 3 or 4 that were just bad. And so that's why we're hopeful that if we have more data.
But if there's ever an event like London Riots, isn't it always going to repurpose one of the badges it has?
Because it's so.
Explain that. Because it's the only thing it has, right?
Oh, so yeah, so that's another point. Our background distribution might not be expressive enough because, for instance, like there are some groups of people, even though London Riots seems like it's a background thing, really what a background distribution is designed to explain is something that if I just picked 1,000 people at random from the population, any 1,000, it would be equally likely that they talk about London Riots. But clearly, like, there might be some groups of people that are more, like, for instance, the Man U group, like, those people tend to be in Britain, and they might tweet more about London Riots than other people, and so it might want to put London Riots in that bad. And actually, you can see as the sampler goes on, like, as these badge definitions get better. In the beginning, it has like London Riots and the Man U badge, and eventually that kind of, it gets taken out. But that's not possible. That's not possible like for everything, I think. So one possibility is you can imagine having something like multiple background topics, or give it some room to, like, give it more expressive. Like you want to have a richer way to express like a background distribution other than just single probabilities for each action.
But even if you do that, there's no guarantee that the learning will stay on the topic you initialize with, right? It can go anywhere. Just because you initialize with a set of people that have this tag in their profile,
well, the prior
you can
on
always repurpose that. I mean, as you demonstrate, you can always repurpose the badges. There's no hard constraint that it has to stay with the tags that it was initialized with. In fact, you don't want that to happen necessarily.
No, but we try to define the prior on that. Like we have those 2 beta priors over the rule kind of variable, and we try to make it such that it gets, like if you don't have a badge and you express that rule, then it's you get severely penalized. But that's still, like, once you have a ton of data,
Then you can't generalize if you do that.
Yeah, so it is a trade-off.
I mean, it seems to me that if all you want is a representation of your model that the user can interpret, you can simply take the badges learned via any mechanism, look at all the profile words
that occur with that badge and just show that as a word clock, tag clock, right? And that describes the badge. Why doesn't that work?
So now if I tell you that I'm not a vegan, what do you do? Like, because if all these are separate, right? Like, if you're saying you're independently...
You report, the question is, how do you report a badge to the user? You still have badges in the model, but instead of associating with some arbitrary word that you use to seed the model, you represent it with the words that actually occur in the profiles of people with that badge.
Oh, okay.
So
So
you take all the people which have been given that badge by the model and make a tag cloud of their profiles, and just say that's the description of their. And that way, if the badge moves somewhere during learning, like it moves to London Rise, that will then get a description of that.
as opposed to whatever rule I defined it.
Exactly. Yeah.
I have a last question. Are some badges better than others in terms of correlations with the kind of user actions that they cannot explain?
What do you mean?
So like some badges are really general, so if I'm a wine lover, I can track anything. But if I'm an Apple fanboy, I can just talk about Apple.
That's definitely, so some people, like, some characteristics don't manifest themselves in your Twitter behavior like others. So, you're like, Apple fanboy probably, if you write Apple fanboy or gamer or something, that's maybe more likely to tweet about that than, you know, I don't know, I like horses or something. I mean, like, there might be, and that's not taken into account in the model.
Do you think there's a way to prune badges maybe? Automatically?
I mean...
Why would you prune a badge?
If it's noise, if you're mostly being in one batch, just it's used as a background. So I guess it's
Can you move badges around such that, like, you know, if it turns out that it's not good enough, like it's not really predicting coffee, or something, like it becomes a background badge, and you have these, you know, I don't know.
Just rename the badge, as I was saying.
Yeah.
Just call it whatever it's modeling, and then it becomes a useful badge.
So again, coming back to that question, so suppose there are two badges. One is extrovert, you are an extrovert, and the other badge is introvert, right? Basically just the opposite. Now for introverts, for the introvert badge, you would actually not get any labels. You have a bias in the data because introverts don't actually say that in their rules. So how would the model sort of take into account these sort of problems? Because I mean, the people
like
have
there's some badges that
people have personality, and every sort of tag on Flickr or on Twitter has a personality of its own, right?
not every badge has the same probability of being expressed, right?
Yes, exactly.
So I mean, we have that's why we have these beta priors on top of that, just to like have that flexibility in the model. But you know, I mean, that's exactly right. Like, it's beyond having this prior on those variables, we don't explicitly model that.
Like Twitter boycotter.
Yeah.
Just a remark, you're probably aware of this, but in Google you can look at the profile.
Yeah.
I think someone sent it around,
You're
right? And then actually look at what they currently think of you, which was fairly low recall, high precision stuff, and you could actually remove stuff if you thought it wasn't actually applicable. So that makes this setting very realistic. That they use it.
It wasn't that high precision. A lot
There's
of
very low
women
precision
in
for it.
computing were labeled as males.
Oh yeah, is that right?
A
Oh,
lot of
yeah.
women in computing they were labeled as males. There was nothing about that.
That's a fair mistake to make prior.
Okay. Any more questions? Thanks for the
Thanks a lot.